Good day, welcome back to Trigonometry. We're still using reduction formula. We are at video 5. Today's example will be where it is more than one set of information that is given with regards to two different quadrants, or even in the same quadrant but two different ratios. Our question reads as follows. Determine the value of each of the following without the use of a calculator if sine of alpha minus 5 is equal to 0 and tan of beta is equal to negative 3 over 4. It also tells us where alpha is an element of 90 and 270, meaning in the second and third quadrant, and then beta is an element of 90 and 270, also in the second and the third quadrant. So the first thing I do here is I write sine of alpha in a form of a ratio in order to express that this is a y value over r value. Now that I have that, I say to myself, where is sine positive? First quadrant or the second quadrant? But it says alpha is an element of 90 degrees to 270 degrees. So the only place that sine will be positive is in the second quadrant. The next one says to me tan of beta is negative 3 over 4. So where is tan of beta negative? Tan will be negative, and where I need to look at between 90 and 270. So either second or the third quadrant. Tan is positive in the third quadrant, so it must be in the second quadrant. Now I draw my pictures and I need to calculate the x value for the sine, and I must calculate here the r value for the tan ratio. So in the sine one, I will have the square root of 13 minus the square root of 5. My answer could be positive or negative x. But because it's in the second quadrant, I will have a negative x value. So my x value will be negative 12 for the alpha ratio. But when I work with beta, it will be 4 squared plus 3 squared will give me 25, and the square root of 25 is 5. Radius is always positive. So I'll have x as negative 12 because it is the second quadrant, and I will have r is positive 5 because the radius is always positive. Now the first thing that they ask me is calculate the cos of alpha. There's two different pictures. I cannot use this picture because this refers to the angle beta. So I'm talking about the angle alpha. So the first thing I say to myself, cos of alpha in the second quadrant, I will have a negative result. So my answer is negative 12 over 13. That is the answer of cos of alpha. Negative 12 over 13. And that's it. Our next question is cos of alpha plus beta. Now it is very important that you know your double angle identities. You can go in 4 different ways with this. You can go in the form of cos alpha cos beta minus sine alpha sine beta. If you do not know your double angle identities, you will find it difficult to answer this correctly. So, after I've written down the extension, now I go and search what is cos of alpha. Cos of alpha, the adjacent side over the hypotenuse, negative 12 over 30. What is cos of beta? Cos of beta, now I go to the sketch where beta is. The adjacent side over the hypotenuse, negative 4 over 5. And so I go on to sine, and remember here, the negative sign in front is applied to both these. So I go to sine of alpha. Sine is the opposite side over the hypotenuse, so it is 5 over 13. And then I go to sine of beta, which is the opposite side over this hypotenuse, so it's 3 over 5. Now that I've got all the values there, now we'll multiply. Negative times a negative will give me a positive, so 12 over 13, and 4 over 5 must be multiplied. 13 multiplied by 5 is 65. So at the back, I've got 5 over 13 multiplied with 3 over 5. 5 times 3, 15. 13 times 5, 65. The difference between 48 and 15 is 33 over 65. Then I've answered my question. Nothing difficult about it. It's just a mere plug and play. Also, do not be fearful. You can type this into your calculator as is. Just remember, here you have to put brackets around those numbers, and make sure that you put a bracket around this when you do the sum, and get your answer straight away. So you don't have to have this step. From there you can go straight to your answer. You will get all your marks for the sum. Now we get to the next sum. This sum is cos 2 alpha plus 2 beta. Now, two double angle identities, and you can have two different outcomes here. You can have different ways that you can write 2 alpha, but there's only one way that you will write sine of 2 beta. 2 beta will only be 2 sine beta cos beta. So for that, you will go sine beta is 3 over 5, cos beta is negative 4 over 5, that must be multiplied. But for cos of alpha, cos 2 alpha can be written as cos of alpha plus cos of alpha. Then it can be expanded to cos square alpha minus sine square alpha. Or it could be 2 cos square alpha minus 1, or it could be 1 minus 2 sine square alpha. You need to choose the one that will really speak to you best. And here, this is the one that I chose, but you don't have to choose this one. You could choose any of the others, you will still get the same answer. So let's look at this answer quickly. Cos square alpha, we go to alpha. Cos is the adjacent over the hypotenuse, negative 12 over 13 squared. It's 144 over 169, positive value. Minus sine square of alpha. Sine square is the opposite side over the hypotenuse, 5 squared. It's 25, 13 squared is 169. So that is minus 25 over 169. We already calculated this one. So 2 into 3 over 5 into negative 4 over 5. So this will be a negative. 2 times 3 times 4 is 24. 5 times 5 is 25. So when I add them on the calculator, I will get my answer as negative 1081 over 4225. To conclude, I would like to say that cos 2 alpha, this substitution that I've done here, could have been also written as 2 cos square of alpha minus 1, or 1 minus 2 sine square of alpha. I chose this one, but you can choose any which one, as long you will still get to the same answer. I conclude by saying, from mathematics and the fourth industrial revolution, we thank you for watching this video and hope to see you in the next one. If you liked it, tell your friends. If you did not like it, but you loved it, please share with us your experiences.